Welcome back viewers. Today we will be looking into binomial coefficient calculation by using the dynamic programming strategy. So we have already looked into this dynamic programming. So we know that we want to find out the optimal solution, the best solution. But what is it? This bigger this problem, if it has an earlier solution, we are going to take it and we are going to put it. So that is going to be overlapping of sub problem. The solution is being taken and we are going to overlap over it and find out the most optimal solution. Earlier videos we have done for knapsack problem, so you can just refer to it if you have any doubts. So this principle of optimality is the main concept behind this dynamic programming strategy. Okay, so today we will look into what is this binomial coefficient. So how are we going to solve it by using this dynamic programming strategy? Okay, so without wasting any time, we will quickly go into what is this binomial coefficient. So now when we are being taught in our schooling a plus b, we very well know it is nothing but a variable a plus a variable b. So here when we just go about with a plus b the whole square, our teachers have taught us it is nothing but a square plus 2ab plus b square. So earlier we have just looked into and little bit of elaboration I would like to do. This is 1 and this is 1 and here we have 2. Okay. So these are the binomial coefficient factors. So still further, if you were good at taking up things, we know that a plus b the whole cube could be some number where we have a factor of a cube plus some number we have to have with a raised power of a square, and we have b here, and then some number has to be here raised to the power a, and we have a factor of b square, and we know it is to something raised to the power b cube. So it is nothing but a cube, where here b to the power 0 and here a cube becomes a square and b becomes raised to the power 1, and here we know that a is raised to the power 1 and it becomes b raised to the power 2, plus we have a to raise to the power 0 and b cube. So here we find a is being decremented, there we find from this side b is being decremented, and you just have. So what is the coefficient here? We know it is 1, 3, 3 and 1. Okay, so how do we go about? Okay, another try. So this could be the factor, and what could be the number? So here we will have 1 and here too we will have 1. So this is going to be 4 and this is also going to be 4 and this will be 6. So how do we normally calculate, or how do we go? We will just quickly look into. Okay, so the condition here is going to be, so if it is going, we will be using our combinatory factor here. So C n comma k. So what is the number here, and based on the coefficient here, whatever it is, we will be calculating the factor of it. So now the formula we have just given as this. I will just take it. So n is going to be 3 and I have it as 3. Okay, so initial conditions are going to be, if it is going to be 0, or it is going to be 1. Okay, so these are the two initial conditions. And this is going to be the main part of it. Okay, so when it is going to be C 3 comma 3, so this is N and this is going to be K. Okay, so this 3 comma 3 is of type N comma N. So what is the answer? It is 1. So here the coefficient of this is 1. Okay, so supposing if I have to take this one, so in the place of K, it is going to be 1. In the place of N, it is again the 3. So how do I calculate here? It is going to be N factorial, that is 3 factorial, divided by 3 minus 1, that is K factorial, into K factorial, that is 1. So 3 into 2 into 1 divided by 3 minus 2 into 1 into 1. Okay, so here it's 1. So the answer is 3 and I find this coefficient is as 3. Okay, so it is going to be easy. So now we will just try with this one. So if it is going to be for power 4 and I'll take this one. Okay, K as 2. Let us look whether it is running fine. So N factorial. So this is N and this is K value. Okay, so N factorial is going to be 4 factorial divided by N minus 2. Okay, into 2 factorial. So I have 4 into 3 into 2 into 1. So 4 minus 2 is 2 factorial. 2 into 1. The answer is 6. Do I get the same 6 here? So this is the formula for finding out the factorial. So now when you just look into this, we can dynamically go fill in the table also. So here what do we have is, this is a recurrence process, again and again we go about by solving. So that is why we have this dynamic programming concept. For getting out this answer, we have this such formula, but we can just go about by solving it recursively by having some sort of a substitution. So now when I have a table structure like this, how do I go about by filling it? So now for 0, that is this value, I do not have any other coefficients as such. It's going to be our 0 only. So I don't have any values as such which are being given. Okay, so for 0, I have 1 as the coefficient. So when it comes to 1, okay, 0 is like I have no variable at all, so it is going to be 1. So here when it is raised to 1, so the first variable and the last variable, it's going to be 1. When it is raised to 2, when I just find out, like, this is going to be my like 2 comma 0. 2 comma 0 is also 1 and 2 comma 2. This is K and these values are N. Okay, 2 comma 2 is also 1. When it comes here, I know that 3 comma 0 is 1, whereas 3 comma 3 is also 1. And I have found out that 3 comma 1 is 3 and 3 comma 2 is 3. Okay, so when it comes to the next one, 1, and this part is also going to be 1. Okay, so in between I know it's going to be 4 and it is going to be 6 and it is going to be 4. another easy trick I would like to tell. So here this summation will be this. Okay, these two summation will be this, and these two summation will be this. Summation of these two will be this, and summation of these two will be this. Whereas summation of these two will be this, and here you don't have nothing, the same value will be there. So that is the easiest part we can just go up with. But when it comes to k element, obviously the first element is going to be 1 and the kth element is also going to be 1. But how about the intermediate element? So it is going to be C of k comma k minus 1. Okay, so this kth element comma this k element. So here n minus 1. So here it is going to be minus 1. Sorry, 1, and we don't know which is going to be the thing. So here it will be n minus 1 comma k minus 1, and for this kth element it's going to be C of comma k. So nth element it's going to be so it just goes above. This is the general formula, or this is the general way we go about by substituting, and this is the combinatory factor where we will be getting the product according to it. Okay, so far hope you have understood what is this binomial coefficient. So now if we have to compute it, so now looking into how this is going to be done using the dynamic programming concept. So in our dynamic programming, as I told you, we have a bigger problem. That is this we have marked up in our small school. This one, okay, if we were interested in, we have marked up this. This formula, we might know, we were not bothered about it. Still further, we found it very difficult and we didn't really look into. But our computational part or our way of solving, we know that it is going to be a different task and we cannot limit to a smaller instance. So for higher order, we have to generalize with some formula so that it will be computed for any point of time or any value given it has to go about with. So here using this dynamic programming concept, we will be using the earlier solution, what we have already got, how we can just go by computing it, and how we can substitute. So in this dynamic programming, we have a little bit of theory which we have to know. We are looking for optimal solution, the principle of optimality. So how do we go about this principle of optimality is, we already know or we already have a solution which is being kept in store, and we are going to take that solution and make use of it and for the further part of it. Okay, so when we make use of it, the time can be reduced, space can be reduced, and we can no need to repeat the same process again and again. Already obtained solution is being taken and it is being used. So overlapping some problem, solution is being taken and it is going to be used. And next one, it is going to be put in a table. So this table structure will enable us to know like what is the solution, how it has already come, and how we can make use of it in future. Okay, so the third one is going to be, it is going to be a recursive or recurrence which is going to be repeated again and again. So this function is going to take place again and again. So it is a repetition which is going to take place. Okay, so hope you have understood what is this binomial coefficient, how it is being calculated. So simple formulas are being used and how this is being computed and how we are just putting it in a table and how do we go about with. Okay, so now we will just look into the generalized formula of how this is going to be computed. So we have an initial condition, this one, that is C of n comma 0 is going to be 1, and we know that C of n comma n is also going to be 1. Okay, so here C of n comma k. This is what this n comma k. How is it going to be taken? So, as I told you, the summation of these two will give you this. Summation of these two will give you this. Summation of these two. So, summation of these two will give you this product. So, if I have to get this, what are the two summations which I have to use? It is going to be summation of these two values. Okay. So, the formula is going to be C of n comma k is going to be C of n minus 1 comma k minus 1 plus C of n minus k and k. Okay, so how do we go about? So now we know. I just drop a thing as okay, 2 comma 1, sorry, 2 comma 0 is going to be 1, and 2 comma 2 is going to be 1. Okay, so making use of this, 3 comma 2. This I already know from these formulas. Okay, so this is nothing but 2 comma 2 and 2 comma 0 as 1. Okay, so now I'm going to compute this one. How do I go about with C of n minus 1 comma k minus 1? So what is that n minus 1? 3 minus 1 is going to be 2 comma k minus 1 is going to be what? 1. Okay, so what is this? 2 comma 2. Okay, so now I don't know this value. So how do I go about by finding out C of 2 comma 1 is going to be C of n minus 1 means 1 comma minus 1 means 0 plus C of 1 comma 1. Okay, so we know anything comma 0 is going to be 1, and anything comma anything, that is 1 comma 1 is going to be 1. So it is going to be 2 as the answer. Okay, so here this particular thing comes under this condition. So I have 1 as the answer, and this 2 comma 1, the answer which I have already got, this one as 2 as the answer. So here 2 plus 3 is going to be equal to 3. So now let us look into whether this 3 as an answer, whether it is going to be correct. So what is n? It is 2, and what is the coefficient power? It is going to be 2. So this one raised to the power 3n, and this one as our new k, it is 2. What is the coefficient factor? It is 3. Okay, so this is how we just go about by solving one after the other recursively. So the formula or the generalized equation for finding out this binomial coefficient is this. Okay, so you have the value with 0, it is going to be 1, or it's going to be the value, same value, it is going to be 1. And this is the formula. From this is the place where you have got the formula. Hope you remember why this has come and how you have obtained it. Now the simplest, easiest part is writing an algorithm. Okay, if you have understood so far, it is very easy for us to write this algorithm too. So this algorithm has two factors or two inputs which have to be given, that is the value of n and value of k. Okay, so you are quite familiar and you know what is n and what is k, and you know that raised to the power of what is going to be n, and which part we are going to look into, that is going to be k's value. So now initially I put one variable I for putting this n, and I have another variable to check whether this n or k, which is minimum. I cannot go beyond a particular instance if it has been wrongly given k n as 2 and k as 10. So it cannot go beyond 2 for the value k. So that is why I am just checking whether the condition is true or not to go about it. So now the first condition, that is n comma 0. So this n value which is being given and this j value is 0, then I have to put it as 1. Otherwise, if it is going to be equal, so if I is going to be the same value of I, that is n is equal to n, then that is also going to be 1. So this is the first condition, that is the initial condition which we are looking. Else, otherwise, it's going to be different. This I value is different and this j value is value less than that n value, then we have to compute with this particular value. So that calculation is nothing but this n minus 1, that is I minus 1, and this j is going to be k minus 1. Okay, so here we have j minus 1 plus this I minus n minus 1 is given as I minus 1, and here we have the k and there we have the j. So this is the direct substitution of this formula which we have taken from this particular table, and where we have to substitute, and this is going to take place. And finally what is going to happen is we are going to return the value for this particular instance, that is what we have calculated here, what we have computed here. We are getting the solution at this point and we are giving it back as the solution. Okay, so now this is a step-by-step initiator of like computing the binomial coefficient. So hereafter you need not mark up or just keep it in store what we have learned, but you can just directly put this formula, or you can just use this formula for computing, and we can very well use the dynamic programming concept, so that already if we have known, we can make use of it and we will not recalculate the same and go about it. So what could be the efficiency of it? So now we know with respect to time, it is going to be n here, which is going to be called, okay, so that is going to make a comparison with all factors of k. Okay, so it is going to be n times k is going to be the time complexity. So how much space is it going to take? It is going to be the n number of instances which are going to be there as the space which is going to be recorded. So here the time complexity is going to be n into k, whereas the space is going to be big O of n. Okay, so this is the complexity factor, and hope you have done an analysis over it, like how this problem is being solved, how it is taken, what is the input taken, how we can compute this binomial coefficient and everything, how do we use this dynamic programming concept into it, and how do we compute it, how do we calculate it, and how this formula is being substituted into this further, and what is the time complexity here, and what is the space complexity. So hope you have understood the binomial coefficient formula under the dynamic programming concept. Okay, hope you have learned something new.